Hello, I'm here to talk to you about global temperature rise. That's our second topic on the list of 8 topics for your project. There are 4 links, 1, 2, 3, 4. I'm going to go through them in order. We're going to start with the first link here, going to NASA. This is the NASA page for global temperature. And as you can see up here, NASA's climate change page is actually including a lot of other information. So we're on the vital signs page here. There's evidence, causes, effects, scientific consensus, vital signs where we're at. Questions. Then you can also see there's other topics here that they're mentioning, and almost all of these are part of somebody else's project for this this climate change project. So if you want to kind of learn more, this is a really good resource for you. NASA's done a really good job of keeping this up online and gathering information, and this stuff is all showing in real time. So as the measurements are made, they kind of get published here. So let's get right into it, huh? Global temperature. What we're looking at here has a lot of jargon or technical terms in it, so we're going to kind of break those down for you. So here it says latest annual average anomaly from 2019. And then here's a little dot where it says, here's an example, right? So an example of an average temperature, of a temperature anomaly, is how much warmer or colder than the long-term average a unit of time something is. Okay, so how much warmer than the average from the most recent year was globally, right? So basically we're taking global average temperature, and anomaly means like how different we are from that. So if you look at this graph here, which this is from NASA's Goddard Institute for Space Studies, which means that this is probably going to be measured with the Goddard measurement system, which is like a satellite system. So here it says the graph illustrates the change in global surface temperature relative to the 1951 to 1980 average temperatures. 19 of the 20 warmest years have all occurred since 2001, with the exception of 1998, which was also abnormally warm. The year 2016 was the warmest on record. This is consistent with similar constructions prepared by these places. Okay, so what this means is this is like kind of a data construction. We're gathering data how we can, sometimes using satellites, sometimes measuring it around the world. Okay, a lot of this can be measured with infrared from satellites, which is great. And we're kind of putting it together and we're comparing it to what it's been like in the past. So average temperature anomaly in degrees Celsius, because everybody around the world uses Celsius, right? So the mean is the average, right? So that would be the gray line, and then it's been smoothed out kind of by a data scientist here. So you can see the gray line would kind of bounce back and forth between these lines, or between these dots, and it would kind of like zag up and down. And then somebody went through and smoothed out the data, so you can kind of read that black line. So the black line follows the trend. So since 1880, the temperature has actually fluctuated a bit, but you can see that lately there's a trend. It's going up, and it's going up a lot. Okay. So that's kind of what this is showing you. And how do we gather this data? I kind of broke it down for you. This data was kind of gathered using satellite temperature measurements from around the world. And if you wanted the full data set, because you're a scientist, you could click on this, but you really don't need that. Let me show you a little bit about what this is going to look like. So this is a really good graph to just kind of show you what it's like in real time, and then you can look at these smaller sections if you want. So here we're looking at the early 1900s. On our graph, and you can see that, yeah, every time we measure it, there's ups and downs, right, for every year in terms of average from 0, but you can see that we were actually low, but as you, I don't know how to zoom out, that's not good. Oh, reset, there we go. As you look at lately, right, we've had some ups and downs, but generally speaking, we're still trending upward, right? So like this is from 2011, but look at where we were in 2019, right? We're up to almost 1 degree total in increase. And you might be saying like, oh, well, 1 degree temperature increase isn't that big of a deal, but we're going to talk about the effects of that in a little bit. So let's take a look at this. This is a time of series. So this is taking temperature recorded data around the world that we had and kind of putting it all over a map of the world to show you how the temperature is changing. So in 1884, this is like a snapshot of that. And you'll see that 0 is white, so that would be like right on average, and if you're below average, it's going to be in blue. If you're above average, it's going to be in the warmer colors. The darker the warmer color, the redder it gets, the higher the anomaly, the farther away from 0 you are. Okay, so let's kind of like watch this go. So this is going through the late 1800s. You can track it right here. So it's taking year-to-year data, and you can see already that we're adding warmth in equatorial places and dry places like Africa. And then you can see for some reason there's some weird warmth over Russia, but it kind of goes away and then comes back. There's some weird warmth over Alaska. It goes away and comes back. But as you can see, we're going to see that that yellow kind of spreading through, especially at our poles. It's going to start there and then kind of work its way through, because the poles, right, they're the coldest places. So they're the ones that are going to increase, or that'll show the increase the most. So as we kind of move through it, you can really see this increase, and it gets really quite drastic as we get closer to now. So we're still back about 40, 50 years ago now, moving through. Okay, so this is the world I lived in when I was a kid. And we're getting pretty close to when you guys were born, and here we go. This is your world. So you can see that temperatures around the world, on average, have increased pretty substantially, okay? And that's kind of what this data is showing. So you might be looking for the how, and this doesn't really give you the how very well, like how did we get this data? I just told you a little bit of it. We are recording this data in different ways, measuring temperature around the world. That's good enough for the how, I would say. And then what does it mean? Well, global temperature is increasing. We can see that. Now, has it gone down before? Yeah, but currently, lately, we've seen this pretty drastic increase. Okay, let's go on to your second one here. Did I just show it to you? I may have just showed it to you. Let's look at it again. Oh, so this is going to be... Yeah, no, this is basically the exact same thing. Oh, man, I didn't realize that. NASA must have added this video last year. Okay, well, those two sources are literally the same. But this is a YouTube video. It's a little bit easier for you to, like, grab it and use it. So if you wanted to open this, like, watch it on YouTube, grab the link and drop it into your presentation. Or you can even embed a video into your Google Slides if you want. If you want help with that, you can just ask me. But if you wanted to embed this, you really could do that so that people could kind of see it. This is the same video. It's going a lot faster, though, so that might be good or bad for you depending on how you visualize information. So it shows the same information, just slightly differently and at a different speed. So now you've seen it twice. Okay, here's a new thing. This is a new graph, and I want to kind of make this make sense. So this is from NOAA, which is another one of our. It's on climate.gov, right? So that's one of our national climate science places. Okay, so NASA, you know about NASA obviously from space and stuff, but they do a lot of other things because they use satellites to measure things and they care about science. So NOAA's another one of those groups. Okay, so if you want to read all this stuff, you can, and it'll tell you a little bit more. I want to hit the highlights. I want to hit this graph. I want to show you a little bit about what this data construction picture came from, and then maybe we'll scroll through some of this stuff. But this is a really long one. There's lots of technical jargon in here. You don't have to know everything about this, but looking at this first thing here, right? So it's talking to you about the heat capacity of the ocean. So basically, water can hold so much heat. And you actually have to put a lot of energy into something like that to raise the temperature. So we're talking about surface temperatures rising, okay? So since we started doing the industrialization that we saw in our world, where we kind of made the world better for people and stuff, well, most people, right? That sort of happened in the late 1800s, early 1900s, industrializing, burning fossil fuels, driving economies, things like that, capitalism, all of that, right? So all of this stuff has caused, since then, a 2-degree increase in global average temperature on the surface. Okay, so it might seem small, might seem like it's not very much, but it's actually a significant increase in heat. Okay, so this extra heat is causing regional and seasonal temperature extremes. You guys have seen that in your lifetime. It's lowering our snow cover and our sea ice, which is places where there's permanent snow or ice, right? It's making heavy rainfall more intense. It's changing habitats and things like that. Okay, so let's look at the highlights before we look at the graph. In 2019, the average temperature across the global land and ocean surfaces was 1.71 degrees Fahrenheit, or almost 1 degree Celsius, above the 20th century average, that's the 1900s, of 53 degrees Fahrenheit. So the global average temperature was 53 degrees Fahrenheit all year round, okay? But it was almost 2 degrees higher in 2019. So that makes 2019 the second warmest year ever recorded by humans. The global average temperature has increased at an average rate of 0.13 degrees Fahrenheit, or 0.7 degrees Celsius, okay, per decade. So every 10 years it goes up a little bit since the 1880s. And it's been going at about twice that rate since 1981, right? So here is that twice the rate. So it's actually a little bit higher than twice the rate. We already know that 19 of the 20th warmest years ever recorded were since 2001, but the 5 warmest years in this time period from 1880, when we started recording data, to 2019 have all happened since 2015. So basically that's the last 5 years, you guys. 9 of the 10 warmest years ever happened since 2005. And like, obviously, if we just started recording data not even 200 years ago, like really not even 100 years ago, well, around 100 years ago, we don't have very much data if you're thinking about the grand scale of Earth, 4.6 billion years, right? But we need to think about the Earth that we live on. since humans have been around, these are the warmest years ever recorded. Okay, so you can kind of see a new record was set on average every 13.5 years from 1900 to 1980. But since 81, every 3 years, we've had a new record on average. Okay, so that's average data, but those are kind of the big highlights. Those are the things you can kind of share. If you can boil those down to make them simpler, you can share those with others and they'll kind of get it. So let's look at this graph. This is a good one. This graph is showing the history of global surface temperature since the 1880s. Okay, so it's basically showing this exact same data just in a different way. So it's showing temperature anomaly, or how different the temperature was on average. Okay, so you can see on the Y global temperature anomaly, and 0 is here. So actually for a while we were in like a little bit of a cold spell in the early 1900s, and then in the 1940s we started to see this change, and it was kind of like cycling back and forth and back and forth. Abnormally high in the mid 40s for some reason. And then you can see that something happened in the 80s really. We just kind of switched over, and now we've seen the temperature just going up and up and up and up and up, basically on average, if you follow this on average, right? There's some years that are higher than others, but it is going up. Like we've gotten to about a whole temperature degree to be different. So if you wanted to mess around with the graph, it gives you instructions for how to do that. So if you want to look at different parts of it, you can do. Okay, so let's look down here. Conditions in 2000. Oh, we're really far along. So this is what 2019 looked like. You can kind of see the temperature rise, and if you take a look at this, you'll see how it's going. And you can see this is actually going through your months, so you can check that out, gather information from that. Here's a description of change over time. Trends from 1901 to 2017, 1988 to 2017. So you can see that, yeah, temperature's increasing. And if you look at the big scale, not so bad. But if you look at the recent scale, oh man, right? This is getting a little crazy. So if you want to read more about what surface temperature is and why it matters, there's some information here that may help you. It might also help you with the future projections. Here you can see another version of that graph showing the temperature. There's some other things attached to this graph that we're going to try to talk about here in a second. So let's go on to this last source. Here's your third or your fourth source. This is that exact same graph from before, and you can see this is taken in the winter months. So that's one additional piece of information that's not given here. It doesn't say if this is taken in just the winter months. This graph is telling you, hey, we only recorded this information in the winter months for the Northern Hemisphere. Okay, so here again is a picture of 2015. This is showing the global average temperature anomaly. That's like a stopped version of that video from your first source. Okay, how do we know the temperature before the 1800s? That's a really good question. So we use these things called proxies, things that record information from the past. So ice cores, tree rings, coral skeletons from coral that was alive at that time. They're proxies. They're things that would have recorded that information. Or we can even dig deep into the Earth's crust to kind of figure that out. And what you do is you measure the particles that are in there, and that can kind of help you reconstruct what the climate or the atmosphere was like. So here's a picture of an ice core, okay, that we would kind of take that to the lab. We'd take pieces out of it, we'd melt them, and we'd count the particles and say, okay, here's how much of this there is in the atmosphere in this year. Okay, and we can tell what year it is. You guys learned about ice cores in December by looking at the layers in the cores. Okay, so this is a whole explanation of that. Now you'll see also this is describing how atmospheric carbon dioxide, so carbon dioxide in the atmosphere, has actually been connected to temperature rise. So you can see that CO2 in the atmosphere has gone up a lot in the last 100 years. And this is telling you about how we reconstruct past climates. So if you want to know more about that, you can find out. And if you want to ask me about it, we can talk about this. So this is actually showing CO2 on one graph and temperature on the other. And you can see that the red and the blue, one's CO2, one's temperature, they're basically connected, right? So as CO2 goes up, temperature goes up. As CO2 goes down, temperature goes down. And yeah, we weren't around this many years ago, right? But we can reconstruct this data based on ice cores. So something to think about. This is just going to kind of break it down for you and explain the process a little bit better. So if you're confused or you want help with it, like read through this. If you need help, just ask me. I'd be happy to explain it to you. This video's gotten exceptionally long though, so I'm going to cut it short so that you guys have some time to actually work instead of just listen to me yabber. See you later.